Hello learners, welcome to Black Slides online learning platform, a platform where you are privileged to learn the sciences, namely physics, chemistry, biology, and mathematics, entirely for free. So on this platform, you learn these 4 subjects entirely for free, meaning that you don't have to pay school fees in order to learn. All you have to do is follow the link to the YouTube channel, which is this channel, and then you are free to choose the lesson of your interest depending on your needs. But like I always say, remember to subscribe to the channel and hit the notification bell so that you don't miss any lessons when they are uploaded. Once again, my name is Mr. Lola. Welcome. We are continuing with the topic called thermal expansion. And this happens to be lesson number 2 of the topic. It's the first topic in Form 4 Physics, Msce Physics. So in lesson 1, we looked at a number of issues relating to the topic. For example, we defined a term known as temperature, which is simply the degree of coldness or hotness of a body due to the kinetic energy of the particles in it. We also looked at the difference between the concepts or the terms heat and the temperature. And using the definitions of the two terms, we looked at their differences. For example, we said that heat is simply the energy that flows from a body which is at high temperature to a body which is at low temperature through, of course, what we call a temperature gradient. That's heat energy. Temperature is simply how cold or hot a body is due to the kinetic energy of the particles in it. We also looked at the difference between the two in terms of their SI units, where we said that the heat is measured in joules, like other forms of energy, and the temperature is measured in kelvins, but it can also be measured in degrees Celsius, as it is commonly measured in labs. All right, we also looked at a number of aspects such as thermal expansion of solids using what is called cast iron bar breaker. So using the cast iron bar breaker, we looked at a description of an experiment that could be carried out to show that solids expand when heated and contract when cooled. Welcome to today's lesson. In today's lesson, we're going to look at a number of issues again, one of which is we would like to seek an explanation, or to explain why we are going to explain why solids expand when heated. Why do solids expand when heated? All right. So we shall do this by looking at the particle behavior. Particle behavior of matter, mainly solids, when they are heated or during thermal expansion in solids. All right, so we are looking at why do solids expand when heated. From lesson 1, we noted that solids do expand when heated. So why do they expand when subjected to heat? So we shall do this by looking at the particle behavior during thermal expansion in solids. Remember that solids are made up of tiny particles, which are called atoms or molecules. All right. Remember that molecules are just groups of atoms that are combined together chemically. All right. So when we are talking about particles, in this case, we are simply interested in the behavior of what? Molecules. The behavior of molecules. How do molecules behave when heated? All right, so this you need to understand very well, because in an exam you'll be required to explain why solids expand when heated. So the answer is what we would like to look at in this lesson. Why do solids expand when heated? So we are saying, first and foremost, you need to know that molecules in solids are closely packed together and are continuously vibrating about fixed positions. So that's the first point you need to think about. So molecules in solids are closely packed and are continuously vibrating about fixed positions. This is typical of all solids. When we are looking at the kinetic theory of matter, for example, you learned that particles in solids do not flow like they do in liquids and gases. All right? So they simply vibrate about fixed positions. They are not so free to translocate, to move from one point A to point B. No, they are in fixed positions, vibrating, such that when they are heated, when solids are heated, what happens to them or to the particles is that the molecules will gain kinetic energy. Molecules gain kinetic energy. Very important. So first and foremost, notice that molecules in solids are in fixed positions, vibrating. But when heat is supplied to a solid, when heat is supplied, what happens is that the molecules will tend to vibrate with large amplitude. So they vibrate with large amplitude. Amplitude is what we call displacement. So the particles vibrate. You know that a vibrating particle or system has a property known as amplitude. So they move. They are displaced from their original positions. So they move up and down, up and down, up and down, with very big displacement or distance, still in a fixed positions. So we are saying when a solid is heated, the molecules vibrate with large amplitude. Amplitude is just a distance. So in other words, their distance of vibration increases. Okay, so this vibration makes them to collide with each other with large forces. So the particles vibrate or collide, they hit, they bombard each other, they collide with each other with very large forces. So remember, one of the effects of force is push. So the particles end up pushing each other far apart. Okay, so we are saying when the solid is heated, the molecules in it vibrate with large amplitude. Look at amplitude as just distance, but we don't use the word distance, we use displacement because there's an aspect of direction there. Okay, so this will make the particles to collide with each other. Okay, they collide with each other. So particles collide with each other, and as they collide, they push each other apart. Okay, so the effect of the pushing of each other apart eventually is that what's going to happen is that the distance between them increases. So the distance between the particles increases. Take good note of that. So distance increases. So since distance increases, like the particles are pushing each other far apart, there's a wide separation. There's a wide separation between them. So because there's a wide separation between the particles, the resulting effect is expansion. So hence solids expand when heated. Okay, so a question that says describe an experiment explain why solids expand. Explain why solids expand. Why do solids expand when heated? That one is a 5 marks question. And those 5 marks can be obtained by writing these sentences. So the first mark will come from the fact that molecules in solids are closely packed. That's the premise of the whole answer, the basis. So molecules in solids, mind you, we are talking about solids here, not liquids. So molecules in solids are closely packed together. First of all, the distance of their separation is not significant. They are very, very close. Okay, and what they're doing in that close compactedness is that they're just vibrating, all right, continuously. That's according to the kinetic theory of matter also. So they are just vibrating, vibrating. So when a solid is heated, now you are looking at supplying heat to the solid. When heat is being supplied, the molecules vibrate with large amplitude about fixed positions. So this again gives you another mark. So you have 2 marks. The next mark will come from the fact that this vibration with large amplitude makes the particles to hit each other, to collide, to bombard. There's collisions. So collisions usually are associated with forces. So they collide with very large forces which push them far apart. Remember that a force is a push. It can also be a pull, but here we are looking at the pushing effect. So the particles push each other apart. All right, and as a result, the distance of their separation increases. So distance increases. As a result, there is an increase in size of the solid, which is called expansion. So remember that this size applies to volume. So there's an increase in volume, there's an increase in area, there's also an increase in length. I hope you understand that. So the fourth mark will come from the fact that the particles move far apart, leading to expansion. So in total, you have 5 marks for such a question that says explain why solids expand when heated. Don't just say they expand because of heat or because of temperature. That's not true. All right, you have to explain in terms of the behavior of particles. How do particles behave when the solid is being heated? I hope we are good on that. Now, having talked about solids, now we can move on to the expansion of liquids. So liquids, like solids, also expand when heated. So liquids expand when heated. So we are saying all liquids expand with varying amounts. In other words, all liquids expand with different amounts. All right. For example, examples of liquids are substances like water, spirit, cooking oil, paraffin, benzene, and others. They are liquids. Remember, by definition, a liquid is any substance that flows like water. That's how we define a liquid in science. So we are saying all liquids, think about liquids, expand when they are heated. And the observations or experiments have shown that the expansion is with varying amounts, meaning that they expand at different rates. Some expand more than others. That's what we are saying there. All right. So in your exams, you'll be asked to describe an experiment. You'll be required to describe an experiment that can be done, which can be done to show that liquids indeed expand when heated. So you'll be asked to carry out an experiment to show that liquids expand when heated. When heat is applied to a liquid, the liquid is going to expand. How can you show that fact experimentally? Remember that these descriptive questions, the way I describe them to you, is the way you need to present them in a manable exam. This is a manable format of answering descriptive questions in physics. So the materials that you'll need will be around the bottom flask. So you shall need a flask. You shall need a capillary tube, a source of heat, a cork, and a liquid. So this liquid can be any liquid like water. It's okay to use water because water is just cheap to find. All right. So once again, when you have given all the materials correctly, you gain 2 marks. That's according to Money paper 2 requirements. So all materials mentioned, 2 marks. All right. If you mention any 3 correct materials, you gain 2 marks again. And when you mention only 2 correct materials, you gain 1 mark. But if you miss a lot of materials, you only mention 1 correct one, you don't gain marks, and the whole description is marked wrong. Right, so fill a round bottom flask up to the brim with a liquid. We said that the preference can be given to water, which is readily available. All right. So fill a round bottom flask up to the brim, meaning it should be fully filled up to the top, up to the ring of the mouth of the flask brim. It's that ring on the mouth of the container. So fill it up. Then you insert a capillary tube through a cork. Make sure that the materials you're mentioning in the procedure are the ones that you mentioned up there. Don't mention something which is not listed. That means you are carrying out a wrong experiment. So the materials you are mentioning in the procedure should agree with the ones that you have given in the under materials. All right. So insert a capillary tube through a cork. We'll see how this is done in the setup. We have a diagram that shows how this is set up. All right. So insert a capillary tube through a cork and the cork and cork the flask, meaning you should close the flask with the cork. And then you mark the level of the liquid in the glass tube. So this is the level, initial, you can call it initial level, the level of the liquid before heating begins. All right. So set up the apparatus as shown in the figure below. So we have a figure in the next slide which is talking about how the experiment is to be set up. All right. Okay, so this is how you would carry out an experiment which can be done to show that liquids expand when they are heated. Okay, so diagrammatically we can show this experiment like this. So we're saying we have a round bottom flask. We have a round bottom flask. We have a round bottom flask. Which is set up as shown here. So this is a round bottom flask. It's clamped. By the way, we did not mention a clamp. It is important that you need to mention a clamp. So there's a clamp there. You can mention the little stand to support the clamp, to hold the clamp, and then the clamp is holding the flask there. So the liquid being observed is water, which we said is readily available. So all this is water up to this level here. That's water. And this one is the cork. That's the cork. So that's the setup. So heat will be supplied at the bottom here, and you need to understand this. 2 things are going to happen. Okay, remember that the water is placed in a glass material. Glass is a solid. and water is a liquid. So when heat is supplied at the point of contact between heat and glass is going to heat up first, and it is going to expand first before the water in it does. So what will be the effect on the volume in the flask? So when the flask is heated first, it is going to expand. The glass is going to expand. What will happen to the space inside? All right. If you said that space in the flask is going to increase, the volume is going to increase somehow due to the expansion, you have said it correctly. Now, when the glass expands, the volume in it is going to increase. That will cause the volume of the level of the water to go down slightly, somehow. Okay? Because it's like by expanding, the glass has created some space which the water can occupy. So the level will go down slightly. After some time, with the glass will transfer the heat to the liquid in it. As a result, the liquid, the water in this case, will now start expanding. That will cause the water to rise up the glass tube to show that expansion is happening, or to show that the liquids expand when heated. Alright, that's very important to note. So we are saying heat the flask. So heat the flask as you observe the level of the water in the tube. Alright, pay attention. So you heat the flask, supply heat to the flask, and pay attention. Observe the level of the liquid, the water in the tube. Like I said, it will be observed that the level of the water falls first. The level of the water falls first. Please, that's a very important examination tip. They'll ask you, why does the level of the water fall first and then it starts to rise again? Why? Okay, so the level of the water falls first and then it starts to rise again. Okay, so the explanation to that is the initial fall, the fall of the water level in the capillary tube is due to the expansion of the glass flask, which gets heated first and then expands. Okay, so the expansion of the flask results into increased volume of the flask. So volume in the flask increases in response to the expansion of the glass initially. So it will lead to the increased volume of the flask. So the water moves in to fill the extra volume. Very important to note this one. Alright, so finally the heat reaches the water. The heat travels. Remember, heat is energy that travels or flows. So the heat energy will be passed on to the water, of course, through conduction. All right. So the heat reaches the water and starts to expand. As a result, the level of the water now starts rising up again. So if you observe, you'll be able to see the thread of water in the tube moving up to show that expansion is happening. Expansion is happening to show that water is expanding. Therefore, this rising up of water shows that liquids expand when heated. So this is the experiment that could be carried out to show that liquids do expand when heated. I hope we are good on this one. In some cases, it is advisable to color the water, to add something like food color to the water. Okay, this is very important also because it will help you to observe clearly as the water is rising up the glass tubing. So they'll ask you in an exam to say, why is it important to color the water in the flask? Okay, it is for easy observation of the water as it is rising up, as it is expanding, because there is some movement of the liquid up the tube to show expansion. I hope we are good together on this one. In case you have questions, please don't forget to leave your question in the comment section so that I should be able to address it. Okay, good. There is another experiment which is associated with expansion of liquids. This one is a comparative experiment in which now you have different liquids and you want to determine which one expands faster than the other. We just mentioned earlier on that different liquids expand at different rates when supplied with equal amount of heat. All right? Please don't confuse this descriptive question with the one we just looked at. The one we just looked at, the previous one, is simply showing that liquids expand when heated. That's all. So you just needed one liquid, which is water. But in this one, where now we are looking at an experiment that can be done to show that different liquids expand at different rates when supplied with equal amount of heat. All right, so you need a number of liquids, like you can have water, alcohol, you can have benzene, or methylated spirit. Of course, methylated spirit is alcohol. You can have maybe cooking oil, you can have ether. Okay, but you have to be careful on the choice of substances, because some of these, like alcohol, ether, benzene, they are flammable. That's why you need to use a water bath. Don't heat them directly using direct flame. That's why you need to use a water bath, because a water bath transfers heat in mild amounts. Okay, unlike when you heat the plastics directly. Yeah, so it's okay where you are using water bath, because these highly flammable chemicals cannot catch fire easily. All right, so you need the 4 identical flasks. So you have flasks, you can call them A, B, C, and D. All right, so 4 identical flasks. Trough is this one, the container, which is acting as a water bath. Water itself to be filled into the trough. Stirrer, okay, stirrer for stirring the water to ensure that heat is being distributed equally. A source of heat and different liquids. So the different liquids that we have here are these ones: water, alcohol, benzene, and ether. But the choice of liquids can change. You can have paraffin, cooking oil, and any other liquids that interest you to use. Next, you fill the flasks with different liquids. So fill the flasks with different liquids to the same height or level, and then place them in the water in a trough. This trough is called the water bath. We just mentioned that, as shown here. That's what you do next to set up this. So once again, in an exam, this is the format that you would follow when you're answering a question in paper 2 of physics, which says describe an experiment that can be done to demonstrate that different liquids expand differently. It's a different question from the one that says describe an experiment that can be done to show that liquids expand when heated. In that case, you simply need one liquid and then proceed. Okay, but here we are comparing. Where you are comparing, you need to have several liquids. So here we have 4 of them to compare which one would expand faster than the other. Thank you. So heat the bath while stirring it. Why we are stirring it? It's because we want to ensure that heat is being distributed throughout the trough, the water. Okay, because if you don't stir, it means only water will only be hot on one area and the other area it may be cold, so it will not be a fair experiment. So they may ask you, why is it advisable to stir the water? It's to ensure uniform distribution of heat. So heat the water bath while stirring. Observe the levels of the water in the flask. So the area of focus, your observation is on the levels of the liquids. What is happening to the levels of the liquids? All right. So you have to pay attention. You have to observe carefully. So it will be observed that the levels of the liquids in the tubes again will fall first. First of all is going to fall, for the same explanation that we gave in the previous experiment, that when the glass tubes, mind you, these are glass tubes, they're like test tubes. When the glass tubes are heated, the glass expands and the volume inside the tubes increases. That causes the liquids to drop because they're trying to occupy the space that has been created by the expansion. Afterwards, the levels will rise by different amounts as the heating continues. So you see, you compare the levels of the liquids, you find that one liquid is highest compared to the other 3, and then you have another one slightly higher like that, and then you have one which is sluggish in moving very slow, okay, to show that it expands very slowly. So you see the liquid levels are at different levels. They are rising at by different amounts. So the results shows that either, if you're to carry this experiment practically, you'd say ether expands most, followed by benzene, while water being the least. Now, in an exam, you need to be careful how you finish your description. This one here, you cannot write it like that. Because it will be assumed that you have done the experiment practically. You have done it, but here we are just describing what needs to be done. All right. So after you have explained all these, all right, you need to say, observe the levels of the liquids in the 4 tubes. Then you will close your description by saying, if the levels are different, then different liquids expand at different rates or by different amounts when heated. That's how you close. All right. If the levels are different, then it means that different liquids expand by different amounts when heated with equal amounts of heat. But if you have done the experiment practically with those liquids that are given, it would be seen that ether is an organic compound, so it's very light compared to alcohol, water, and benzene. All right. So ether would rise very fast. It has very low intermolecular forces. Of course, we talk about that in relation to intermolecular forces, all right, the viscosity issues and all that. All right. So ether expands most followed by benzene, while water being the least. Of course, the order will be the highest will be ether, then benzene, then alcohol, then lastly water. Water because of issues of maybe hydrogen bonds and the high intermolecular forces, issues of viscosity, etc. But all in all, what we are saying is the above observations shall show that some liquids expand more than others for a given rise in temperature. That's very important to note. So, thank you very much. We have come this far. This was lesson number 2. Now, we meet again in lesson number 3. In lesson number 3 of the topic, thermal expansion, we are going to be looking at the thermal expansion of gases. But before we do that, we are going to also have an explanation of why do liquids expand when they are heated. So we explain that again in terms of their molecular behavior. Once again, I expect to see you next time in the next lesson, lesson number 3. But as usual, before I go, I want you to answer these 4 questions. All right? And I really long to see your answers to these questions. In whatever way possible, try to share with me the answers. All right. So number 1, we are saying, explain in terms of molecular behavior why solids expand when heated. We looked at that today in this lesson. Number 2, explain why the level of liquid drops slightly. This should be slightly. It has to be slightly. Yes. So we're saying this is supposed to be slightly. There must be an S here. Slightly, not meaning not much, just a little bit, and rises when the liquid is heated. We also looked at this one today. Then number 3 and 4, be careful there. Describe an experiment that can be done to show that liquids expand when heated. This one, you just need to use one liquid. Only one liquid is enough. One liquid is enough. You can use water, you can use benzene, alcohol, whatever, but it has to be one liquid. Then you discuss based on that. But number 4 is a comparative question. You are comparing several liquids. Describe an experiment that can be done to show that different liquids expand with different amounts when supplied with the same amount of heat. I've seen students messing up. Instead of answering this question, giving the description of this one, they end up giving as if they are answering question number 3. Or they're given question number 3, but they end up answering question number 4. So you have to be very careful there. Once again, my name was Mr. Poch Lolo. I love to leave you, and we meet again next time. For now, it's bye-bye.